When a vehicle brakes hard, there is a problem that can cause the driver to lose control, even when the braking system is working perfectly. If the braking force becomes too high, the wheels can stop rotating and begin sliding across the road surface. And when that happens, the vehicle loses much of its ability to change direction. To prevent this, vehicles are equipped with an anti-lock braking system, or ABS. In this video, we'll see why a locked wheel is dangerous, how ABS detects when a wheel is about to lock up, and what is actually happening inside the system. Let's imagine a vehicle travelling down the road. As long as the wheels are rotating normally, the tyres can transmit forces to the road. These forces allow the vehicle to accelerate, brake, and change direction. But during hard braking, something different can happen. If the braking force exceeds the available grip between the tyre and the road, a wheel can lock up. Instead of rolling, it begins to slide, and once a wheel starts sliding, it loses much of its ability to generate lateral forces. That's why a driver can no longer effectively steer a vehicle with locked wheels. The main purpose of ABS is to keep the wheels rotating while the vehicle is braking. The solution is to momentarily reduce the braking force before a wheel locks completely. This allows the wheel to regain traction and continue rotating. But before the system can do that, it first needs to know what is happening at each wheel. Each wheel is equipped with a speed sensor. This sensor continuously measures the wheel's rotational speed. If you're interested in how it works, we have a separate video dedicated to that topic. The information is sent to the ABS electronic control unit. Thanks to these sensors, the system always knows how each wheel is behaving. If one wheel begins slowing down abnormally fast, it may be a sign that it's about to lock up. The ECU continuously receives information from all of the sensors. Its job is to detect when a wheel is losing traction. But detecting the problem is only part of the challenge. The system also needs a way to control the hydraulic pressure reaching the brakes. That's where the ABS module comes in. This component sits between the master cylinder and the wheel brakes. Inside are several components that allow hydraulic pressure to be controlled automatically. These include electrically controlled valves, a hydraulic pump, and a network of internal passages through which the brake fluid flows. At first glance, it may seem like a complicated system, but it's actually much simpler than it looks. Each wheel is connected to the ABS module through its own hydraulic circuit. Each circuit is controlled by two valves. Let's focus on a single wheel. The first valve, known as the inlet valve, controls the flow of fluid from the master cylinder to the wheel. The second valve, known as the outlet valve, controls an alternative path leading to a hydraulic accumulator. Both valves are electrically actuated by solenoids. When the control unit detects that a wheel is about to lock up, it can activate these valves several times per second, independently adjusting the braking pressure at each wheel. Let's see how this works. Under normal conditions, the inlet valve remains open while the outlet valve remains closed. This allows the master cylinder to transmit hydraulic pressure directly to the brake caliper. If the module detects that a wheel is decelerating too quickly and approaching lockup, it can close the inlet valve. At that moment, the wheel becomes isolated from the brake pedal and the pressure remains nearly constant. But if the wheel continues slowing down too rapidly, the system must reduce the braking force. To do this, it keeps the inlet valve closed and opens the outlet valve. Now, some of the brake fluid can leave the brake line and flow into an accumulator. As hydraulic pressure decreases, the force applied by the caliper also decreases, allowing the wheel to speed up again. Once traction is restored, the outlet valve closes and the inlet valve reopens. Pressure begins to rise again, and the process repeats. By increasing, holding and reducing pressure in this way, ABS can continuously regulate the braking force applied to each wheel. Earlier, we mentioned that when the outlet valve opens, fluid flows into accumulators that temporarily store brake fluid. Let's take a closer look at how they work. Each accumulator contains a piston and a spring. As fluid enters, it pushes the piston and compresses the spring, storing both hydraulic fluid and mechanical energy. But for braking pressure to increase again, that fluid must be returned to the circuit. This is where the hydraulic pump comes in. The pump is driven by an electric motor and contains small internal pistons that continuously perform suction and discharge cycles. During the suction phase, the pump draws fluid out of the accumulators. During the discharge phase, it sends the fluid back into the high-pressure hydraulic circuit. This allows the fluid that was removed from the brake line to be reused immediately. While the valves regulate pressure at each wheel, the pump continuously recovers and recirculates the fluid needed to keep the system operating. This entire process happens several times every second. Now let's see how everything works together. The driver presses the brake pedal. Hydraulic pressure begins to build. One wheel starts approaching lockup. The sensor detects an abnormally rapid deceleration. The ECU determines that the wheel is losing traction. It then actuates the valves inside the ABS module. Hydraulic pressure at that wheel is temporarily reduced. The wheel begins accelerating again. Traction is restored. The system then reapplies braking pressure. This process occurs independently at each wheel and can repeat several times per second. Meanwhile, the driver continues pressing the brake pedal. These rapid pressure fluctuations create the characteristic vibrations that drivers often feel when ABS is operating. And that concludes our explanation of ABS. Don't forget to leave a comment with the systems or components you'd like us to explain in future videos. Thanks for watching.